Welcome to Hardware Addicts, a proud member of the Destination Linux Network. Hardware Addicts is the podcast that focuses on the physical components that power our technology world. In this episode, we're going to discuss IBM's new 2nm concept and what this could mean for all the future products. We're going to dig into the manufacturing process at a high level, which is just a thing of geek and sci-fi dreams. You're going to love it. There's freaking lasers and plasma. We're getting all into it here. Then we're going to head to the camera corner where Wendy will discuss lithography. So sit back, relax, and plug in because Hardware Addicts starts now. I'm Ryan, your tech guide through the universe, and with me today are my two co-hosts, Wendy, a resident photographer extraordinaire and hardware enthusiast, along with Michael, the software sage and hardware Padawan. Let's find out what tech adventures everyone has had this week. Michael, what did you do, man?
So I did some stuff with my keyboard, and by specifically, there's this thing that people say that keyboards are the nastiest things about someone's house. So I decided I'm gonna clean it today, and then found out that is 100% accurate. It was nasty. It's clean now, so that's good. It didn't change the feel of it or nothing, but it turns out that it's a collector of
Keyboards, the toilet bowl of computers.
Yeah, for sure.
I have a couple tricks here that I like to use. Spray air obviously is amazing, but it's expensive. You buy these cans and cans of spray air. So I got an electric compressed air duster that I will have a link to in the show notes. You plug this thing in, it has a bunch of attachments that make it different sizes. So something for keyboard, you have a really thin nozzle attachment like you would in the spray air can. And then you just turn it on and knock the dust not only off your desk, off of your CPU fans. Of course, hold the fan before you hit it with the direct air so it doesn't spin and destroy the bearings. And also for your keyboards, it's fantastic as well.
That sounds like a great idea, but we have sticky dust here in Idaho where it doesn't seem like you can use enough compressed air to get the dust off of it. Plus, I've also found that it doesn't remove long lady hairs from the keyboard either. They just get stuck in between the keys. So
I've
then
never heard of sticky dust. Why do you have sticky dust?
I don't know, but it's everywhere. And I think it's just from the desert environment that I live in. Dust is everywhere. It's all over the place. You can't get away from it. You will clean, you will dust something, and then it's immediately dusty again. That is just the type of environment that I live in here. So it doesn't matter how much compressed air I use. Let me put it this way. We have so much dust that I do not put new screen protectors on until I tell my husband, all right, so you need to take a longer shower so the moisture can build up in the bathroom and I can use that moisture to get the dust to go down so I can put a new screen protector on without getting dust under it.
Wow.
That's an interesting environment to have to deal with.
Yes.
Well, that best of luck with that.
Well, for people who live on Earth,
yeah, exactly. If you don't live on Mars, you can use this.
You can use this electric duster. It's going to save you a ton of money. It's far more powerful than the dust cans, and because those spray air cans, they also run out of pressure. So the initial spray is great, and then the longer you hold it, of course, you can end up freezing something, which can also ruin components, by the way, and different stuff like that. So it's just a much better solution. It's going to push the air harder, and you're going to knock out a lot of stuff. Also, the Rocat keyboard, the Vulcan that I have, is really interesting in that the keys are raised above the frame enough that any hairs or anything, you could actually, there's enough space in between the keys, you could just pull it right out. Whereas a lot of keyboards are really tight and confined together, and they're not raised up out of the frame. And because of that, lots of gunk and stuff gets stuck in there, especially if you're eating Doritos or Fritos or Cheetos, Michael,
or
while you're typing on your keyboard.
Yeah, any kind of Edo if you want. Yeah.
Any type of Edo. Yeah.
For sure. Oh, it's kind of funny because you mentioned that. I didn't even notice that until I cleaned it today, but this keyboard I have has raised keys, except there's this weird ledge on the top and bottom of the keyboard, which puts it in an insert. so it's raised and then also still annoying to get to. Like that's an interesting
Mhm.
design that I've realized today I do not like. And I was actually kind of interested if is there any kind of keyboard that actually makes it simple to clean? Like that should be a thing that they put on like the box, like easy to clean. 'Cause
Especially people when they tell me they're like, I buy used keyboards all the time. I'm like, man, that's I don't know.
Yeah.
That's like buying a used toothbrush sometimes. I feel like you could, but should you? I don't know.
Yeah, maybe not.
So Wendy, what have you been up to?
Well, I seem to have gone all in on the Surface devices. If you listen to the episode of Deal and Extend that just dropped, you've heard me talking about this. I have now my favorite pawn shop, and this is one of the few places I found that even though the rest of technology has gone crazy in price, they've actually kept their stuff really close to true value instead of the crazy market value right now. We have two Surface devices that we use on a regular basis. My husband has claimed a Surface Book that he's now taking with him wherever he's traveling. He's using in the living room, back and forth, which has been really nice for me and definitely given me more time to do stuff on the computer when I need it instead of him like, "Are you done yet?" He just goes and takes his laptop out there. That's pretty easy to use. And then I've been packing a Surface Pro 6 around with me and been absolutely loving the device. Though I'm not a huge fan of Windows and Microsoft themselves, hardware-wise, these have been really solid devices. When I was in there last time, I saw a used Surface Pro 3 for an amazing deal, and I was already on the lookout for a laptop for a gift. And this is going to be the perfect gift for the person that I want to give it to. Right now, it's running Elementary. I haven't played with it too much after I put Elementary on, but the advantage of Elementary was it's easy to use. You're able to navigate the App Store really nicely. They have a pretty App Store, and it's nice to find the type of app you're looking for. And it worked with touchscreen right out of the box. So
Nice.
yes, which is crazy cool. On most other Linux OSs I've put on there, you've had to install the custom kernel to use with it. But Elementary was super slick. It's got touchscreen stuff on it, and I haven't had to mess with any custom kernels.
So, Mr. Hardware, what have you done this week with potential topics that might pertain to this show?
Well, guess what? I fell so in love with the HP Omen that I've talked about that I bought another one.
Wow.
My son has recently got into PC gaming, like this week, literally as we're talking, his first 2 days into full-on PC gaming, like where he doesn't want to touch the PlayStation, he wants to be on PC. And I love this for a couple of
Nice.
reasons. Number one, he gets to learn all of the keys on the keyboard, typing, launching programs, all of those type of things. And two, one of the issues as he's gotten better in various games is that console players, when you have this cross compatibility in gaming where you're cross platform, what happens is the console gamers just get stomped because while with aim assist and everything else, it helps. When somebody has a mouse, it's just so much faster to flick your wrist and do a complete 360 or turn or have multiple keys for different variations and things. So he was getting to the level at 8 years old where he was competing and winning a lot of these games that he was playing against other people online. However, he was constantly also getting destroyed if that person online, because some of these games will actually tell you if you're playing against a console player, a PC player, he was getting stomped if the person was a PC player because they could just move so much quicker. So now that he's moved to PC, first of all, it only took him like maybe 4 hours to completely adapt. I expected it to take way more time for him to get used to playing these same games with the mouse and keyboard. And number two, I think there's also skills there that they can use in the future of learning the keyboard better, right? Memorizing where the keys are, at least on the left half. Might not be able to type anything on the right half of the keyboard, but on the left half, he's got that down pat with WASD, ZXC, all of that stuff. So I ordered another one so that he would leave mine alone, my Omen alone. And so we have another one coming in, and I think the Omen's probably one of my favorite laptops. It can game and it runs Linux like a dream. And it's fully repairable. And of course it's HP, so it's got a great supply chain. if you're looking for a good laptop that can game or do video rendering or the high-end stuff, I'm just in love with this line.
That is a very strong statement to be like, I really like it, so I got another one.
Yeah, exactly.
That's really good. Also, the hand-eye coordination of PC gaming is an interesting thing that he's going to learn. That's going to be a very valuable thing in the future, and just in general, really. But it's kind of funny when you said the 4-hour transition, and it made me go, yeah, that took me. I'm still working on it. Yeah,
I know, right? Kids are so much more adaptable, which is why you really want to start them out young. Because what I thought would take, I'm like, now you're going to get frustrated. This is going to take you a week to be good at. And he's over there stomping people and a few hours later. And I'm like, wow, okay,
that's good.
Never mind.
Yeah.
Kids can learn stuff really fast. And I think a lot of times we underestimate them. So,
For sure.
but I think PC gaming for a kid, if you can get a good PC gaming machine for a good price out there, and of course nobody can get GPUs, so laptops, like I would love to build him a machine, but who can get any parts right now? So the
Right.
laptops with the stuff inside, that's the best option at the moment to get them rolling.
Nice.
So you're saying part of my problem is I didn't start playing video games, until I was in my 30s, so I'll never be good.
I didn't want to say anything, Wendy, but
But it's true.
but it's true.
I mean, it's kind of true. You can even if you start late on certain games, you can build up skill. It'll take forever, but it's possible. I did it for one game, and then every other game that Ryan and I play, it's very bad. Like, anytime we play a first-person shooter, it's basically like we're competing in who's the worst. This episode of Hardware Addicts is brought to you by DigitalOcean. DigitalOcean announced the app platform service, and you need to check it out because it is a really cool solution to build modern cloud-native apps. So with the app platform, you can build, deploy, and scale apps and static websites super easy and very quickly. Simply point your GitHub or GitLab repository to the app platform and let it do all the heavy lifting for you. It handles the high scalability and zero infrastructure management. What does that mean? Well, you simply just point your GitHub or GitLab repository to it, and it will handle the infrastructures like the app runtimes, the dependencies, and all that sort of stuff, including your SSL certificates. It will automatically create them and manage them and renew them, as well as help you with DDoS attacks. All of this so you can push code to your production in just a few clicks. And also, you can do so with little to no customization because the app platform uses open cloud native standards and automatically analyzes your code, creates containers, and runs them on Kubernetes clusters. As a listener of the Hardware Addicts podcast and a member of the DLN community, you can get started for free. Actually, better than free, because DigitalOcean is giving you a $100 free credit when you go to do.co/DLN. Again, if you want some free credit, free money on DigitalOcean, you can go to do.co/DLN and you get started on DigitalOcean's app platform. And we want to thank DigitalOcean for sponsoring this episode of Hardware Addicts.
All right, so IBM develops 2nm. Now, we were all excited on this show when AMD Ryzen came out with 7nm, but that, my friends, is yesterday. 5nm, that's for hipsters. 2nm, that's the new future out there. And I was so excited about this announcement. And it's interesting to think that this innovation wasn't announced by AMD or Intel or NVIDIA or Apple, but IBM. Now, IBM was the maker of my favorite processor. For those who watch the Destination Linux podcast, where we have video in the background, there's a little frame of different processors that I've held onto. And one of those is the Blue Lightning. They manufactured this desktop 75 megahertz CPU that I absolutely loved. It was my first machine that I built. And IBM is the company that unveiled this 2nm proof of concept chip that packs more than 50 billion transistors into a package the size of a fingernail.
Yeah, that's crazy. Although, it's really interesting because they've been doing these kinds of research things for years, and it's really interesting that they were the ones to get to this point. And by the way, you said 5nm for hipsters, so I'm going to go back to I'm just going to stick with the 5nm because I'm a hipster, and that's how I'm going to go with it.
No matter what happens.
No matter what, 5nm. And
that's how hipsters roll.
Yeah, exactly.
And ever.
Exactly. It's the when it gets mainstream, I don't want it anymore. But the size of the fingernail, made me laugh when I saw that because it's like, which fingernail? We talking about the pinky, the index finger? Which one? Does it matter?
The
Probably
thumb.
not.
And
Oh,
whose thumb?
well,
And what, because you have giant thumbs,
yeah,
people with giant
exactly.
thumbs, small thumbs. Yeah,
Exactly. And we need
My
it. We
6-year-old's thumb is way smaller than mine.
right.
we need to have them verify what kind of fingernail they're referring to.
Well, I think it's just kind of an idea of how small this package is and how much they've packed in there, right? Putting 50 billion of something on anything
Yeah.
is quite an accomplishment. For comparison, AMD's Zen 2 had 3.8 billion transistors,
Wow.
and the Zen 3 had around 4.15 billion transistors on there. You made a good point, though, Michael, that IBM is a research partner. So they have partnerships with a bunch of different manufacturers like Samsung and Intel. They do the research for them, they create the patent, and then they let the manufacturers kind of go do their work. So IBM's behind a lot of these gains in things like 7 nanometer, et cetera. Their research was critical into these technologies coming around. But I love seeing that IBM got kind of the full credit here in a lot of the news stories because that research, if it didn't exist, we wouldn't be producing this stuff in a lot of cases. So it's awesome. I wish IBM would still create CPUs and send them out there into the world because I loved it when they did. But this is the second best thing. So to put this in a timeline of what's to come, you have TSMC, the Taiwan Semiconductor Manufacturing Company, and Samsung are expected to release 3 nanometer chips in 2022. So just because this proof of concept is out there doesn't mean we're going to see it tomorrow in a new CPU that's unveiled.
Disappointed.
I know, right? we won't get any big announcements from Intel or anybody anytime soon with them. But IBM, the 2 nanometer, their partnership, I'm hearing rumors is with Samsung specifically right now, somewhere around 2024. We might see it maybe in a phone or somewhere else. So it's a little ways off. But again, the fact that they're already working on the future like that when we've just kind of settled on the awesomeness that is 7 nanometer and Intel still catching up on that, I think is awesome that we're already down to 2 nanometer.
Yeah, that is pretty awesome. Like I remember like last year we were gushing over the 7 nanometer, and that's just like in comparison, it's ridiculously like it just makes the 7 nanometer seem so bloated and that sort of stuff. It's just pretty awesome. But Intel will eventually get to 10, right? Someday.
Yeah, they've got some 10 out there, and I think Intel's going to do great. I don't want to bash on Intel, but come on, Intel, catch up.
Well, so one of the things when I was doing my research on some of this, that when it comes to this kind of technology that they're using to create these kind of chips, one of the things that I read is each company had said, okay, this is where we want to be with this technology. And that supposedly Intel has set their sights really, really high, so teeny, teeny, tiny. But now looking at this with IBM and 2 nanometer, how small exactly was Intel planning to go as their first chip?
It's interesting. I know on Intel, I'd have to go back and look, but I believe Intel had a graph of their kind of lifeline of what they were hoping to accomplish. And we know they missed a lot of that kind of a product cycle. And I thought 2 nanometer was their ultimate goal that they were trying to hit. And you're absolutely right. A lot of times they'll come to these manufacturers and say, here's the goal that we want to hit. And they work on that. And if you set something at 2 nanometer and we haven't even gotten to 7 yet, AMD comes in, sweeps up 7, Samsung comes in, sweeps up 7 and 5, and Intel's like, we're still waiting on our 2. It's going to take a lot of time to get there. I mean, IBM's gotten there now, and Intel does have a partnership with IBM. So there's a chance Intel could be one of the first to grab this up and use it in a production system. But the 2 nanometer is really interesting because IBM is claiming that it's going to be 75% more efficient than 7 nanometer. 75% more efficient. We know how efficient 7 nanometer is. If you have a Ryzen laptop now with the 7 nanometer CPU inside of it and the power consumption compared to an comparable Intel processor, there's a difference. It's a substantial difference. And you're talking about now going to 2 nanometer at a 75% more efficiency there is pretty interesting. Also 45% more performant, which is pretty awesome.
I do hope that Intel's partnership decides to, like, let's just use this because it would give us what we wanted.
It's so important because battery technology, it goes through its phases, just like CPU technology does. I think we've made some gains in battery technology, but the next gain we don't know when it's going to be. So when you have the ability to create the same amount of speed and efficiency in a processor, but consume far less power, you kind of, without having to have that battery change, you're still going to have longer lasting devices, longer lasting phones, longer lasting laptops, and things like that, which is, of course, going to be a huge win to the consumer out there. Now, to do this, IBM employed single pass extreme ultraviolet lithography on the front end of this chip, which is called EUV. This is the most fascinating sci-fi geek out thing you can go out there and study.
Wait a minute.
It is so incredibly cool.
Is this where the lasers come? The freaking lasers that you said in the intro?
There's freaking lasers here, but there's even more than freaking lasers. If you're into Star Trek, you're going to just love all of this stuff I'm going to talk about. In EUV, a power source converts plasma light at 13.5 nanometer wavelengths. Then that light bounces off several mirrors and hits a wafer and imprints this image in here. Now, this is a really big deal considering we experienced 100 times shrinkage of transistors when EUV came online, which is very recent here. Like, this is cutting edge technology because the major products started around 2018, 2020, from what I could find, with this technology when it was first used. So this is very fresh. This is very new way of utilizing these wavelengths, utilizing this converting plasma into light here.
And to put this more into a perspective, think about the very first chips. They were drawing them on poster size pieces of paper, taking a picture of them and scaling them down to 1:1, and then using that to help print these chips, these transistors. Now we have them teeny tiny already and scaling them down even more. I mean, massive changes in technology over time.
That's a really good point and really cool thing to go back and look at, the fact that they used to hand draw these and then keep shrinking it down. It's, I don't know, the difference between how Disney made animation movies in the past and how they make them now using CGI and things. How it worked kind of in the previous generation before EUV, not quite as far back as manually drawing them, is we use something called deep UV with ultraviolet light, and that was at 193 nanometers. Now, EUV, remember, 13 nanometers. This is 193 nanometer wavelength, which was focused through a mask, or what they call the blueprint, through a lens that imprinted them on light-sensitive chemicals to a piece of silicon. That's the really easy, simple explanation. So basically think like how a projector works. With extreme ultraviolet light using the 13.5 nanometer wavelength, and because of the fact that that 13.5 nanometer wavelength will get absorbed by darn near everything at that size, they have to put this in a vacuum and then have these mirrors do the actual imprinting. But Michael, here's the part you're going to love. It gets even cooler. Because we can't just use freaking lasers, man. Not at this stage. Not with EUV.
Yeah, not just lasers. What else do we need?
Photon torpedoes. I mean plasma.
Well, close enough. I'll take it.
Yeah, plasma. And to get the plasma, they vaporize 10 particles with a laser, creating laser pulsed plasma. And this is the light source that imprints this into silicon.
That's awesome. I don't even know what most of that means, but that's awesome.
Okay, so imagine shooting little tin BBs at a microscopic scale into this vacuum, and then this laser shoots it and breaks it apart into basically just dust. And the light, the plasma light that's created from that reaction there, is the light that's then focused to create an image onto the silicon.
Okay, thank you. I get it now. And yes, I was right. It's awesome.
It's so super freaking awesome. Like, think about the fact that when you go and you get a CPU, what does it cost? $500-$600, maybe $999. It's still cheaper than the cost of a stupid designer purse that somebody goes out and buys, made from in a sweat factory out of cowhide, that the one at Target was made the same way. It costs less than that right? Louis Vuitton or whatever stupid name brand people go out there, and think about what goes into making that CPU that you have sitting in your computer right now. It's freaking awesome.
Yeah, this is very Gucci.
Wow.
I think I just threw up a little bit in my mouth.
Yeah. The fact that you knew that is amazing. But it's funny because, my wife sometimes likes to have some designer stuff. And when I see the price tag of the stuff, I always compare it to something technology wise. I'm like, do you realize you have to have a level 10 factory to produce some of the components that I put into my computer with thousands of people and these amazing lasers and plasma and everything else? And it costs the same amount as a stupid purse that's made of leather. This doesn't make sense. It doesn't add up. Whatever value's wrong. And this technology, though, is just so incredible to me.
So it blew my mind this just to even see that they were making this in the first place. Because having the 5 nanometers, that was far off. I expected that to happen in a few years or whatever, and I expected this 2 nanometer thing to happen eventually, but maybe a decade or two. Not as like there, it was only a few years away, but it said like 2024, and that's not very far away from considering how like massively, like astronomically complicated this would be to do, and with like Moore's law saying that the technology would continuously get better and better on a certain period of time, and it like even doubling. In fact, to me it felt like that was slowing down a bit in terms of not necessarily CPUs or whatever, but it just in technology, it just seems like we were getting to like diminutive returns kind of thing. But to have this come out, I mean, it's just mind blowing.
2 nanometer is amazing. 50 billion transistors is amazing. I don't even think our minds can comprehend how small this is, and the fact that we're able to manufacture this is incredible. But the manufacturing process itself, to me, is one of the most exciting and awesome things that I've seen be manufactured. I mean, who thought of this? Like, they have to come up with ways to keep the dust from getting onto the mirrors and things like that, because they're exploding it with these lasers and creating this plasma, and then using this technology, of course, through the mask to get this imprinted onto silicon. It's so sci-fi. Like, you could read it in a book and go, oh, that's a really cool explanation, or see it in a Star Trek episode and assume that's sometime in 1,000 years from now where that would be taking place.
Yeah.
Like, it's that cool.
It does seem
but
like
somebody
science
came
fiction.
up with this idea.
Well, and that's one of the reasons why it is going to be a little bit before it comes to the masses, is the mirrors getting dirty is currently a problem, because that tin that's being evaporated goes everywhere, and then you coat the mirrors, then the process becomes less efficient. So working out some of those details are the slowdown to us having it sooner
Now,
than
they
later.
use EUV today to create some of the chips, so it's not like it's something that's not in production, but you're absolutely right that it does slow it down and it creates inconsistencies, and therefore you kind of have a lottery of chips that you get and where that lottery lands. But it's such a cool process. IBM's 2 nanometer chip will also employ a tweaked voltage control, which allows it to scale from low voltage applications like smartphones and consumer electronics to data center applications. I think that was your point, Michael, that this would be used in server world, and definitely the amount of power savings capabilities there and the power increase would be absolutely amazing. We're also going to probably see this technology used in everything from cars, and now there's chips in darn near everything. We talked about it last episode that car manufacturing's hit because of the chip shortages, and basically televisions and monitors and everything we use today, refrigerators, all putting chips inside of them. So this technology, in this way of manufacturing it, will extend well beyond just the CPUs we put in our computers, which is kind of cool to think about in some ways and scary in others, and go everywhere. But less hungry chips and awesome research by IBM, who also has been behind amazing research in the past. All in all, I was just super excited to see this and hope that maybe by 2024, this shortage of all of the CPUs and GPUs and everything else will have gone away, so we can actually play with the 2 nanometer something.
Yeah, and then maybe this could be helped with they could use freaking lasers for their crypto mining.
I like it, Michael.
I hate both of you and your freaking lasers.
You know you like it. Freaking lasers. I don't even know what that's from, but it's so iconic.
Austin
It's
Powers,
from
man.
Austin Powers. And
Yeah.
sharks
How do you
with
not know
fucking
that?
laser beams.
Because
Give me your geek card. It's gone.
Because it's such a dumb movie.
It is a dumb movie,
It's a
and it's
national treasure,
been
Wendy.
15 years. Sorry.
Yeah, baby.
I know the other stuff.
When Ryan first mentioned it on whatever show it was, I had no idea what it was from, and my husband was just about dying laughing. So he
Yeah.
had to bring up that scene on YouTube to show me what the freaking laser beams was
Magneto
from.
gets me.
Magneto gets me.
This episode of Hardware Addicts is sponsored by Bitwarden. Bitwarden is the password manager that we use and trust. Bitwarden lets you set up things like a PIN to easily access your password manager, as well as additional authentications, such as master passwords and adding phrases to fingerprint security, all to keep your passwords safe. Bitwarden is the easiest and safest way for individuals, teams, and businesses to store, share, and sync their sensitive data. Go to bitwarden.com/DLN to get started for free. Bitwarden is a password manager that I use and trust because it is 100% open source. You can self-host it, and they do security audits, sharing all of that information with you. Go to bitwarden.com/DLN to get started for free. Want to help out this super awesome open source company? You can get their premium account for just $10 per year. What do you get with that? 1 gigabyte of encrypted file storage, 2-step login with YubiKey, U2F, or Duo, Vault Health Reports, TOTP Authenticator storage and generation, plus priority customer support. Make the smart move like many of the community have and go to bitwarden.com/DLN to get started for free. If you're like me though, you'll want to show some appreciation and sign up with that premium edition, especially since it starts at only just $10 per year. Thanks to Bitwarden for supporting this episode of Hardware Addicts.
All right, Wendy, take us into the camera corner. What do you have for us today?
Well, all of this talk about lithography has sent me on a deep dive into exactly what it is. And before you had your photograph where you could just take a picture, you needed to have a way to share artwork. And this is one of the ways that it had come up to do. And when researching some of this, it actually reminded me a lot of negatives from a camera. The most old school way to do this type of print is actually with limestone and was first developed in 1796. So you take this, whatever size you need, limestone block, you would draw your picture on typically with a grease pencil, grease pen, something like that, because you're using water and oil to kind of make this image, to make this print block. Then you'll go ahead and treat it with an acid. So that means everywhere where your initial drawing, where your artwork or text is, that acid won't touch it. So it makes all of that area more porous and more susceptible for water to get into. Then you do a cleaning. You will re-grease it, treat it again with acid, clean it again, and then you are ready to use this block of sandstone for printing, which is actually really cool. I watched a video of a lady modern day printing this way in Germany with some of the original limestone that is quarried from this specific place in Germany where the first limestone came from.
That's
for
awesome.
this process. Super cool stuff. Modern printing in this way, you can still use it for art or text, even though the printing press became far more easy for mass text. It's still a great way to do art that way. But now they'll still do it with metal or plastic sheets, and you're using the exact same principle. Water and oil don't mix. So you will etch your art in acid, and then the oil or grease paint, whatever you want to call it, will fill in those gaps, and then everything else gets coated with water, so it's just the grease in those specific areas that can be transferred to your image. This process is, at its base level, so simple. You can make your own at home with just stuff you have lying around the house. Aluminum foil, vinegar, of course, water, and then you'd have to find a way to draw your picture on of some sort. I've seen soap used, and it works fantastic. So you don't even need to go out and buy a oil crayon for this, you can do it with soap and create your own at home.
We actually have some paintings in my house that use lithograph technology to basically take the original artist painting and then reproduce it onto another surface like stone or metal and those type of things. And it's amazing because the amount of details that you get out of that type of print. And also they hold their value a lot more than, say, if you just did a standard paper reproduction of an art scene or something like that.
Yeah, absolutely. Because of the etching, especially if you're starting with a really good base plate for something like this, that is what gives you the quality in the end to have such crisp, sharp lines. Whereas some other forms of reproduction, especially if you're scanning, though we do have some amazing art scanners these days, some of that detail would be lost, where you're not losing that with the high-end lithograph techniques. So, of course, you can't start diving into this method of creating art without diving more into how these chips are made. And I went down an absolute rabbit hole.
It was fun though,
with
wasn't
this
it?
thing.
It's so worth doing your own research.
Yes, it was an absolute blast. Now, this old school stuff is just plain old lithography. This new way is called photolithography. So it's very specific in the fact that it uses light in order to create these different, in a way, it's almost an image as it's creating it on your chip. So what it starts with is a mask. So in the traditional way of making photolithography, say, take your standard 14 nanometer chip from Intel. The mask or the map that is used to start with is made out of quartz. It needs to be see-through because you're passing light through that. In this case, think of your photo negative. Now, these can be used in two different ways depending on what you put down on your wafer or the part that that light is going to hit. You can use chemicals that make it softer. So as you do the chemical treatment, it washes away those areas. Or you can use chemical that when it's hit with those light, it wants to build material on top of it. So those two different ways in which this technique can remove or build up material, depending on what you're doing, what you're trying to make, what you're creating. Now, the laser will go through that mask that's been made, and it usually uses an argon fluoride laser, which, as Ryan talked about earlier, has a wavelength, the UV wavelength of 193 nanometers. Now think about that. You have a CPU that is 7 nanometer technology, but your wavelength in nanometers is so much bigger than the actual chip itself. So that's where we get this extreme ultraviolet lithograph. We're still using ultraviolet light in both of these two cases, but the energy required between the two is so much more. That means our trusty argon fluoride laser is not powerful enough to produce that 13.5 nanometer UV wavelength that we need in order to create these super sharp, teeny tiny details. So that's why we need the first laser to melt that 100% elemental tin, and then we shoot that tin with a second laser. It's only 30 microns wide. We shoot this droplet of pure tin with this laser. That's what turns it into plasma. All of that energy for being hit with that laser is then converted into this extremely short wavelength UV light. Absolute crazy sauce. Now, when we're thinking about data and all of this other stuff, it's your standard map that comes for just your regular old 14 nanometer chip. Guess how much information is on just one of those masks? Do you guys have a clue?
No idea.
1 billion.
70 quadrillion.
70 quadrillion what? You're giving me numbers, but you're not telling me like...
Wafers.
That's because we want you to give us the answer.
All right. So just one of those masks contains 14.69 petabytes of data. Petabytes of data.
Wow.
Now, for your standard 14 millimeter chip, it needs 50 of those masks to make the chip. And why? In using this old school way, which is still really pretty new, of creating these 14 nanometer chips, your wavelength is so large that you're not as fine-tuned as you can be with the EVU version of it. So that means with the newer version, with this extreme ultraviolet version, because your wavelength is so much shorter, you're able to make much finer, precise cuts in creating these type of things on your wafers. But that also means that it takes a huge amount of power in order to create these things. Just crazy the amount of power they have to draw, because only 2% of the protons that are created when you hit that tin with the laser are actually converted into hitting that wafer.
Photons.
2%.
Photon
That's it.
torpedoes. I told you photon torpedoes came into here.
Apparently,
Photon
it does
torpedoes.
sound like this is like 100% photon torpedoes.
Yes. And this is really interesting because this whole process you're talking about has a lot of application in the CPU world. But as you talked about at the beginning, this also has application in the photography world, in the art world, because lithography is something that's used there at a obviously much different scale and purpose. But the same concept behind being able to replicate something through these masks, or in case of a photograph or a painting, the original painting and photograph, and be able to replicate it with extreme detail, the process is there. I mean, different, but the same concept.
Exactly. It's one of those things that helps keep maybe certain artworks around much longer. So the original can be stored and kept as clean and precise as it can be, because paint and canvas, paper can really only last so long. So we need technologies like this, which can give us the lastability of these prints, of these artworks, of our images, and at the same time to keep the originals as long as possible.
Absolutely amazing sci-fi stuff that we're living in the generation that's doing it, creating it. And I love how these technologies, from a limestone, from photography, from paintings, preservation, all the way through the amazing when you get into CPUs, lasers, and photons and plasma and all of this, all interconnect and have a relationship with each other. It's kind of like when those new products come out and they're like, this technology was created by NASA for your pillow or something like that. You know, that one technology gets applied into multiple industries out there to solve similar problems.
Oh, yeah.
Could you imagine storing other data like this, where you can fit so much data on one piece of this? How that technology could be used that way? You could store all the pictures you take in your entire lifetime on a teeny tiny little piece
Challenge
of silicon.
accepted.
And all I need is some tin to vaporize with
Right.
a laser.
There you go.
And also be okay with only keeping 92% of the data.
No, only 2% of the photons created
Right.
will help make.
Come on, Mike.
I know.
the data.
Keep up.
That
But
means
I
you
know
need-
it's just funny to me because it's like, maybe they're not photon torpedoes then. Maybe like it's a photon shotgun.
Because
because they're
Yeah, they're
going
going
everywhere.
everywhere.
Kick him-
Yeah, you
Can someone
can't.
kick him off the show? Anybody have the power to do that here? No.
No, because I'm pretty sure both of you run
Yeah.
this network.
I veto
so-
getting kicked.
I veto. Well, I hope you enjoyed this episode. I enjoyed researching this episode, and there's obviously a lot more details and information related to this manufacturing podcast. We're giving you the high level that will hopefully get you drooling and thinking about going out there and doing some more research on your own, because it's easy to go to the store and buy some of these things, but to understand how they're made and how much goes into making them really drives that addiction for hardware for me, to understand how awesome some of this stuff is that these scientists and engineers are coming up with. And that's it. Our 36th episode of Hardware Addicts is a wrap. Thank you for listening to the show that brings you your bi-weekly tech fix. If you're not all lit up on tech yet, what's wrong with you? First of all, be sure to check out all the amazing content on Destination Linux Network. Head to destinationlinux.network, because we have so many great podcasts and YouTube partners out there with so much content like this that will fill your brains.
Remember, there's no such thing as too much hardware. Learn, build, innovate, and grow.
We hope you enjoyed the show, and we'll see you next time for another lithographic episode of Hardware Addicts, where we all love freaking lasers.
Freaking lasers. No, Wendy? No freaking lasers?
Not participating.